You just finished a massive energy calculation. You remembered the formulas, you filled the page with your working out, and you feel great. But what if you open your results months later only to see a massive 0 for that entire section? It happens, and your final exam grade literally depends on what we are about to uncover today.
Yeah, a total devastating 0 on a high-value question. It is a complete nightmare scenario, but we see it happen to thousands of incredibly hardworking Cambridge physics students every single exam cycle. They think they nailed it, but the marks just aren't there. So, why did a seemingly perfect answer totally bomb? Well, today we are cracking the examiner's code. You're going to learn exactly how to become a literal data detective to secure those critical grade boundaries. Because getting a top-band grade usually isn't about how much you studied, it's about how you structure your response for the person grading it.
Now, you might think just rereading chapters 6 and 8 on energy, work, and power is enough to pass. Spoiler alert, it isn't. You can memorize those chapters word for word, giving yourself a totally false sense of security. But ordinary revision fails because it doesn't teach you the mark scheme. Knowing the physics in your head does not automatically mean you know how to prove it on paper.
Just take a look at this list of fatal mistakes. These are the silent killers draining top-band grades every single year. Missing units? Writing 500 instead of 500 joules or 500 watts instantly kills your marks. Rounding too early in a multi-step efficiency calculation? That makes your final answer mathematically wrong. Or what about graph axes errors? If you misread a scale that went up in 2s instead of 1s, you completely invalidate your data. These aren't physics failures. They are exam technique failures.
In just a moment, I'm going to show you the exact examiner clue that completely transforms your answer from a devastating 0 to full, unarguable marks. It's a total game changer. But first, you need the framework that makes that clue completely obvious when you're sitting in the exam hall under extreme time pressure. So, here is your bulletproof shield, the 4-step strategy for maximum marks. Concept, evidence, reasoning, and wording. Whenever you face an explain, describe, calculate, or evaluate question, you do not just start writing down whatever pops into your head. You systematically run through these 4 steps. Let's break them down.
Step 1 is the concept. You need to instantly deploy the correct physics terminology. No generic fluff allowed. If a question is about a falling object, your concept is the conservation of energy. State it. Doing a calculation? Write down the exact equation for power or work done before you even touch your calculator. Plant your flag in the correct topic immediately.
Step 2 is where you become that data detective. Evidence and data. You have to physically pull evidence, substitute values, and mathematically prove your work. Do not do the math in your head. Write out the specific numbers from the question directly into the equation you just wrote down. Examiners cannot give you method marks if they literally cannot see your evidence on the page. Steps 3 and 4 are all about locking in those marks with scientific reasoning and examiner wording. You've got to link your substituted data back to the concept and actually fulfill the command word. If they ask you to evaluate an energy transfer, you need to weigh both sides, not just describe what happened. Fulfilling that specific command word is absolutely non-negotiable.
Okay, let's put this to the test with a practical challenge. Take a look at this genuine, totally flawed student answer for an energy efficiency question. They wrote, the energy transferred is 500, so it's highly efficient. You see this all the time when students are rushing to finish the paper.
All right, act as the examiner right now. Take a few seconds. What are the fatal mistakes here? Run it through our 4-step framework. Is there a defined concept? Evidence? Sound reasoning? What is horribly wrong with this response?
Look at the massive difference here. The flawed answer on the left is missing units. 500 what? Joules, watts? Plus, highly efficient is totally vague subjective reasoning. Now look at the top band answer on the right. It states the exact equation, substitutes the values, gives the proper units in joules, and locks in a mathematically proven 50% efficiency conclusion. Boom, maximum marks, minimum effort.
Before you even think about moving on to the next question, you must run this final checklist. Did you check your significant figures? Are the units there? Did you verify the graph scales? Running this check takes maybe 5 seconds, but it literally saves you from losing an entire grade boundary. Treat this like an absolute rule.
But wait, applying this framework to a standard calculation is one thing. Look at these source requirements for practical investigations and data analysis. This is where the Cambridge syllabus really shifts gears. Knowing energy stores is great for paper 4, but paper 6 requires a completely different, highly analytical mindset.
The stakes go through the roof when the command word asks you to design a practical experiment for energy transfers. Suddenly, you're not just solving math, you are the lead scientist. You have to handle independent, dependent, and control variables. You have to consider safety and instrument precision. All the textbook theory in the world won't save you if you can't structure an experiment.
Weak practical improvements and wrong variables will absolutely tank your score. You could nail every single energy efficiency calculation, but if you drop the ball on practical design, you're handing away incredibly easy marks. This is exactly where prepared students suddenly hit a brick wall.
So the next crucial clue for those full marks is waiting in our practical investigations explainer. We're going to take this exact 4-step framework we just learned and apply it directly to designing flawless practicals. You simply cannot walk into your exam missing this piece of the puzzle.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Seriously, click the next explainer right now to master your practical skills. Don't leave your final grade to chance. Become the ultimate data detective. Because ask yourself, if you can't prove exactly where the energy went, did you really understand the physics? See you in the next explainer.